Hello dear students of class 2 medical and non-medical respected teachers. Today I am going to discuss a very important topic, potentiometer and its applications. This is the end of chapter current electricity. Now what is potentiometer? Potentiometer is a device that is used to find potential difference and hence e.m.f. of a cell. Its construction. It consists of a wire of uniform area of cross section having a number of segments, usually 4, mounted on a wooden board in series with the help of strips like this between ends A and B as shown in the figure. Scale is also provided to note the reading, the length of wire. Between A and B, a battery of e.m.f, key K, rheostat and ammeter is connected in series. Now to understand the principle of potentiometer, suppose a voltmeter is connected at the end A and other end of the voltmeter is connected to the jockey J. Now, what this principle of potentiometer states that potential difference across any section of the wire of the potentiometer is directly proportional to length of that portion of the wire, provided constant current is flowing through the wire. So V is directly proportional to L. So when you move as a jockey at end A and when will you move along the length of the wire, you will find reading of voltmeter increases. That is V is proportional to L. So to prove it, using Ohm's law, V is equal to IR or V is equal to I into R, rho into L upon A. Now if wire is of uniform area of cross section, A is constant current is flowing through the wire, rho is constant for a given material of the wire, and V is directly proportional to L. So potential difference across any section of the wire of the potentiometer is directly proportional to length of that portion of the wire when constant current is flowing through the wire. So this is used to find or to compare e.m.f. of two cells. This is one practical application of potentiometer. Now take a potentiometer as usual. It is in the form of a wooden board of length about 1.2 meter. Take potentiometer, connect battery, key K, rheostat, ammeter in series between ends A and B of the potentiometer. At end A, two cells whose EMFs are to be connected. Their positive ends are connected at end A, negative ends are connected to the two outer terminals of a two-way key, and central point is connected to the galvanometer and then connected to the jockey J. So first of all, insert key K so that constant current starts flowing in the potentiometer. Then insert key in the gap number 1 so that cell E1 comes into the circuit. E2 is out of circuit. Then find the balancing length. Let it be L1. So E1 will be proportional to L1. Because when no current is being drawn from cell, its potential difference is nothing but EMF. Now take out key from gap number 1 and insert it in gap number 2. Again find the balancing length. Let it be L2. So E2 is proportional to L2. So divide E1 upon E2 is equal to L1 upon L2. Very simple experiment. So by finding the balancing lengths when E1 is in the circuit and then E2 is in the circuit, we can compare their EMFs. To verify, connect voltmeter directly to the cell separately, note the readings of the voltmeters, find the ratio. These two ratios will come out to be in very close to each other with an experimental error. So we can compare EMF of two cells using potentiometer. This is one of the application of potentiometer. Second, we can find the internal resistance of a cell. Again, take a potentiometer, make the circuit as usual, battery of e.m.f. E1, key K1, rheostat RH, ammeter in series at and A connect positive terminal of the cell whose internal resistance is to be calculated negative and to the galvanometer to the jockey as shown in figure, and make another circuit, connect resistance box and key K2 with the cell as shown in figure. Now first of all insert key K1, don't insert key K2. After inserting K1, find the balancing length. That is, no current is being drawn from this cell when key K2 is open. So that balancing cell will give you EMF of this cell. So E will be directly proportional to L1. That L1 is the balancing length when key K2 is open. Then insert key K2 and take out some resistance from resistance box. So some current is being drawn from this cell in the circuit. Now its EMF will be reduced, and that reduced EMF is called terminal potential difference. Let V is equal to terminal potential difference. Now balancing length will be directly proportional to terminal potential difference, V proportional to L2 when R is not 0, when the circuit is closed. So find E upon V, that will be L1 upon L2. And we know that internal resistance R is given by E upon V minus 1 into R. So it will be L1 upon L2 minus 1 into R. So knowing two balancing length L1, L2 and R, we can find internal resistance of the cell. So these are the two applications, practical applications of potentiometer. Be happy, all the best. Subhadda Palav. Good luck.